Hello students, I am up and down and round exercise 5.5 solution. First question, find the length of the chord of a circle where the radius 7 centimeter and perpendicular distance is 6 centimeter. So if we are taking a circle, with center O, then take a chord. This is the chord. We need to find the chord length. For finding the length of the chord, the information given here is the radius of the chord is 7 centimeter. So this is the radius 7 centimeter, and one more information given, the perpendicular distance. So from center to the chord, if we are dropping the perpendicular, that distance is 6 centimeter. This is the chord. AB is the chord, and OC perpendicular, length radius 7 and perpendicular distance 6 centimeter. So we know that the perpendicular, this is 90 degrees. So in triangle OBC, BC is equal to square root of hypotenuse OB squared minus OC squared, another side squared. So BC is equal to 7 squared minus 6 squared. BC is equal to 49 minus 36. So length of BC is equal to square root of 13. BC length is square root of 13, but we need to find chord AB length. So AB is nothing but twice BC, because we know that OC is perpendicular to AB, means AC is equal to CB is equal to half of AB. So AB length is twice BC. So length of AB is equal to 2 times root 13 centimeter. This is the length of the chord when the radius is 7 centimeter and perpendicular distance is 6 centimeter. This is root 13, 2 root 13 centimeter square. Second question, explain why the following statement is true. If the perpendicular distance of a chord from a center is D and the radius is R, then the chord length is twice this. So we need to find why it is true. We are taking a chord then radius and the perpendicular distance. The perpendicular distance of a chord from the center is D. This is given D. And radius R. Then length of the chord is 2 times R squared minus D squared. If you are taking A, B, O as the center, C, then in triangle OBC, BC length we know very well, OB squared minus OC squared. So BC is equal to square root of OB squared R squared minus D squared. Then AB length is equal to twice BC. So length of AB is equal to 2 times square root of R squared minus D squared. So the statement is true. Third question, in a circle, if the distance of a chord AB from the center is twice the distance of another chord CD from the center, then we can conclude that CD is equal to twice AB. Give reason of your answer. Let's take a circle. In this, we're going to take two chords. One chord is AB. Suppose this is AB. And another chord length is CD. Say this is CD. Then center of the circle is O. If we are taking a radius, this is radius of AB chord. Then this is the radius of CD chord. Then perpendicular distance. Say chord A, B and C, D. Then PQ, perpendicular distance PQ. In a circle, the distance of a chord AB from the center is twice the distance of a chord CD from the center. So, if OP is perpendicular to AB and OQ is perpendicular to CD, and here given the length of OP is equal to twice OQ. The distance of the chord from the center is twice the distance of a chord CD from the center. Then we can conclude that CD is equal to 2AB or not, they are asking. Then this is the radius, OB is the radius, OD is the radius. Let's check the ratio. Then we can conclude it. That is, in triangle OPB, the length of PB, the length of PB is equal to square root of R squared minus twice OQ squared, twice OQ squared. That is PB is equal to, for suppose if we are taking OQ is equal to distance D, then OP is equal to 2D. We will take like this. Let OQ is equal to D, then OP is equal to 2D. We will replace that here. Instead of using the same letters, we can use 2D squared. 2D squared. So, R squared minus 4D squared. So, what AB is equal to twice square root of R squared minus 4D squared. Next, in triangle OQD, the length of QD is equal to square root of R squared minus D squared. So, the chord length CD is equal to twice square root of R squared minus D squared. So, if we are finding the ratio of these two, that is CD is equal to AB, means find AB divided by CD. If we are getting constant 2, then the given condition is correct. Otherwise, the given condition is not correct. AB is equal to 2 times square root of r squared minus 4d squared. This is 2 times square root of r squared minus d squared. We can cancel 2 and 2, but we cannot cancel that 2. So, AB by CD is equal to square root of r squared minus 4d squared divided by square root of r squared minus d squared. It is not a constant value 2. If we are getting AB by CD is equal to 2, then we can conclude that CD is equal to CD by AB is equal to 2, then we can conclude that CD is equal to twice AB. So, now the given statement is wrong. It is not a correct statement. No, it is not a correct statement. Then 5.6, exercise 5.6, in a circle with center O, the center angle AOB is 60 degree. If the radius of circle is 12 centimeter, what is the length of the chord AB? So, take a circle. In the circles, O is the center, then angle AOB. If we are taking a chord, center O, now we are joining this, we will be getting a triangle O to B, then A to O. We will be getting triangle AOB. AB is a chord, O is the center, the angle here given is 60 degree. The radius of the circle is 12 centimeter. What is the length of the chord AB? So, what to do here? In triangle AOB, OA is equal to OB. Both are same distance, same length because they are the radii of the circle. So, when OA is equal to OB, which implies angle OAB is equal to angle OBC because OBA, because they are the opposite angles of same side. When the sides are equal, opposite angles also equal. So, in triangle AOB, angle AOB plus OBA plus BAO, angle sum of these three is 180 degree. Now, these two are equal angles. These two are equal angles. Angle AOB is 60 degrees given. Say for these two angle is equal to x degree. So, x plus x is equal to 180 degree. 2x is equal to 180 minus 60. 2x is equal to 120 degree. So, x is equal to 60 degree, which means angle OAB is equal to angle OBA. Both are 60 degree. So, all the angles, this is also 60, this is also 60. Therefore, triangle OAB is an equilateral triangle. Equilateral triangle. So, length of the chord AB is the radius of the chord. All the sides are 12 centimeter. If one angle of an isosceles triangle is 60, then all the angles are 60. It is an equilateral triangle. So, radius length is nothing but chord length. Second question, let A and B 2 points on a circle with center O or their points XY on a circle on the same side AB such that angle AXB is different from AYB. So in a circle, for the first subdivision, it is given in a circle, if A and B are 2 points on the circle, same side, if A is one point and B is another point, are there XY on the same circle? X also here, Y also, XY also same side. If we are joining this, the angle AXB and AYB, the points XY on the circle, the same side AB such that these different from AYB. Angle AXB is equal to angle AYB. The reason, same segment angles. Both are same segment angles. We know that the same segment angles are equal. So definitely they will not differ each other. So the answer is no. No, AXB will not differ from angle AYB. Both are same segment angles. Both are same. Second question, is it true that AXB is equal to AYB? Then X and Y lie on the same side of the circle. No, that is not true. Suppose AXB is equal to AYB means always they could not be same segment angle. They may be in the opposite sides also. Suppose it is not necessarily they should be the same side, same segment angles. Opposite side angles also same. If x is a point, AB is here, this is AXB, X is a point, Y may be on the opposite side also. If Y is here, then also both the angle can be equal. These two angles can be equal. So answer is no. It is not necessarily same segment angle. Angles are equal. They may be in the opposite direction also. Third subdivision, if AXB is equal to AYB and X and Y do not lie on the circle, does the circle through ABCX all pass through Y? Yes. When ABX, then they can pass through Y also. Find X in the given figure. So we can see the 4 vertices A, B, C and D lie on the circle. So A, B, C, D is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. So angle D and angle B are supplement to each other. Angle D, angle B is equal to 180 degree. Opposite angles are supplement to each other in a cyclic quadrilateral. So angle D plus angle B is equal to 180, as well angle A plus angle C is equal to 180. Angle D is given 100 degree. Angle B is equal to 180 degrees. So angle B is equal to 180 minus 100. Angle B is 80 degree, which is X is equal to 80 degree. Thank you.